Factor x squared plus 9xy plus 20y squared. This problem is very similar to the last few problems, but there's one difference. There's no leading coefficient in front of the x squared. It's just 1x squared. Now, we recall when we have a trinomial where the leading coefficient is 1, we can use the unfoiling method instead of the AC method, which is nice because it's less work. But in this case, when we factor it and we get two binomials, it's not just going to be x plus one constant and x plus another constant, because we can see that the polynomial has y's in it. So we know that we're going to start off with x's because x times x gives us x squared. But instead of having constants for the second terms, a constant times a constant would give us a constant here. But what we need to end up with is not just a constant, not just 20, but 20y squared. So the way that we can adapt our method for this is to put y's inside those parentheses. So instead of x plus some number and x plus some number, it's going to be x plus some number times y and x plus another number times y. Let's figure out what those two numbers are going to be. It works just like before. We need them to have a product of 20, and then we need them to have a sum of 9. So we need two numbers with a product of 20 and a sum of 9. Those numbers are 4 and 5. But now, instead of x plus 4 and x plus 5, our answer is going to be x plus 4y and x plus 5y. Just like the problems that we looked at earlier, where we used the AC method, the binomials had x's and y's, and we're going to have the same thing here. And the general rule here is going to be, if we ever have a trinomial in the form x squared plus some number b times xy plus a constant times y squared, whenever we have a trinomial in this form, when we factor it, it's going to be x plus some number m times y times x plus another number n times y. Right? In this case, we had x squared plus 9xy plus 20y squared, and that gave us x plus 4y and x plus 5y. So you can see how these fit the forms that I just wrote there. We can adapt the unfoiling method that we've used in the past just a little bit now with this extra y in each of the factors to fit what we need it to be.